So, yesterday I wasn't here. The day before we did separation of variables for general solutions. Today we're talking about particular solutions. The the slope field is unnecessary. It's just there to show you that we have all these possible solutions. We will have one eventual solution, so we can graph it if we really wanted to, and we probably will just to show you the difference. Okay, but it's not really necessary to actually answer the question. Okay. Now, one thing I did not do yesterday, I see yesterday. One thing I didn't do Monday. So let's go back here to the previous notes real quick. All right. When I did the natural log over here, it should have been the natural log of what? X. So natural log of absolute value of y, right? Gives you, what was it, x squared plus c? I think that's what it was. When you do the e substitution, we got, was it 1/2 x squared? Okay. All right. So we have absolute value of y equals e to the 1/2 x squared plus c. Now, the problem I didn't address, and I need to just make sure I make up now because it's going to play a role here. We have absolute value. What does that mean my answer should have been? Plus or minus. So if you want to change that to plus or minus, I think you have to do that for part 4 as well. Oh yeah. No. But again, you have the notes. I don't have them written up here, right? So just basically, I just need you to change that to plus or minus out front. So yeah, was it y equals plus or minus c e to the 1/2 x squared? Yeah. So some of that. So yeah, do the same thing with number 4 just to make sure you have that correct. Okay. Just a little correction notice. That's all. All right. Okay. So we're going to do the same thing. The difference here is we are going to be actually solving for C in this case because they give us a coordinate, give us x, y, so 1, 1. So let's go ahead and do the separation of variables, but before we do that, we do need to square the x and the y, so dy over dx equals x squared, y squared. So that's going to give you 1 over y squared dy equals x squared dx. Now you can write that if you want as y to the negative 2 to make the integration a bit easier. So we are going to integrate. And what do we get? All right. Now, again, we don't need to worry about the c on this side because I'm just going to add it over, subtract it over. It's just going to give you another constant. And then we get what? 1/3 x cubed plus c. Now, you have the choice to either solve for c now or solve for c once you have y by itself. It really makes little difference. I prefer to go ahead and solve for c now, though. So, we are going to plug in 1 and 1 for at y next. So, negative 1 equals 1/3 plus c, basically. So, that gives you negative 4/3 equals c. So, we have negative 1 over y equals 1/3 x cubed minus 4/3. And it might be better to write this as negative 1 over y equals x cubed minus 4 all over 3. Now, to get y by itself, you need to basically change all your signs. So 1 over y equals 4 minus x cubed over 3. And then raise everything to the negative 1 power. So y is equal to 3 over 4 minus x cubed. Now, that does mean that there is a vertical asymptote at whatever the cube root of 4 is. Okay, I don't know what that value is, but there is a vertical asymptote somewhere. But we know we have this coordinate right here. If you had to graph this, right, and we're going this way. That'd be perfect. But we can see that this right here, these flat, all these lines on the y-axis are flat. That does mean that's a horizontal asymptote that has slopes of 0, so you're not going to cross that. So that's what the graph would look like. Now, there again, there's probably another side over here somewhere. Okay. I don't know. But yeah, that's what it looks like. You don't have to do that side, though, because we weren't giving any information over there. But there you go. There's your particular solution. All right, number 2. Same setup. Multiply both sides by y, multiply both sides by dx. We get y dy equals 2x dx. And then we integrate. What do we get when we integrate? Yep. Now I'm going to go ahead and multiply both sides by 2 first to make it a little bit easier. So we get y squared equals 2x squared. And I'm not going to change c because 2 times a constant is still a constant. So now we can plug in x is 2, y is 1. So 1 is equal to 2 squared is 4 times 2 is 8 plus c, which gives you negative 7 is equal to c. So y squared is equal to 2x squared minus 7. And then when you square root both sides, what do you get? Plus or minus the square root of 2x squared minus 7. However, only one of these is going to work. Okay? It's only going to be positive or negative. And to know which one, just plug in your values. All right? So if I plug in 2, do I get positive 1 or negative 1? Okay. So if I plug in 2, we get well, this should be 1, right? So square root of, that kind of tells you what it has to be, right? It has to be what? It has to be positive. So yeah, y is equal to just plus. Or, again, you don't need the plus. 2x squared minus 7. Now, graphically, we know at 2 we have this value at 1. So, again, there. Something like that. All right. This is the explicit solution. The implicit solution would include the other side. Solution. So the explicit solution only has the top part. The implicit solution would have both. Because the implicit solution is a hyperbola. Yes.
What top part is has to do with explicit?
I believe so, yeah. So I think we're primarily focused on the explicit solving for y. But it basically tells you to solve for y. All right. So here divide both sides by y plus 2, so we get 1 over y plus 2 is equal to, well, dy equals to ex dx. All right. Oh, this one's really fun, by the way. Yeah.
Where you set that.
Yeah. So if we take the integral, what do we get? Natural log of the absolute value of y plus 2 equals e to the x plus c. So what makes this so fun is what do you have to do to get y out of that natural log? Yeah, you have to exponentiate both sides. So I'm going to have e to the x. That's what makes it fun. So absolute value of y plus 2 is equal to e to the x plus c. All right. Yeah. So go ahead and plug in the 0 and the 1. Well, what am I supposed to do with this? What's going to happen with that? Yeah. So that's the value of y plus 2 is equal to c e to the ex. All right. So yeah. All right. We plug in 0 for x and negative 1 for y. We get after that negative 1 plus 2 equals c e to the 0. Now, negative 1 plus 2 is 1. The absolute value of 1 is 1. What is e to the 0? 1. So I get c e to the 1. And that means c is what?
1.
Yep, 1 over e.
My beach one.
I have no idea. I don't think so, though. I think I would have saw those.
Oh, boy.
Oh. So, now, if we plug that back in, let's say we plug that, well, again, it is a coefficient, so we have absolute value of y plus 2 equals e to the x over e. Now, you can write that as absolute value of y plus 2 equals e to the x times e to the negative 1, which you can in turn write that as e to the x minus 1. So now the other day we brought down c. This time we put it back up. Am I done?
Mm-hmm.
No, y is not by itself. Yeah, so y plus 2 equals plus or minus e to the x minus 1. Y is equal to plus or minus e to the x minus 1 minus 2. Now, in order to get, if I plug in 0 to get negative 1, okay, would that have to be a positive or a negative? In order to get negative 1 here, would this have to be a positive or a negative? If I plug in 0, plus or minus e to the, well, what's e to the 0? 1 minus 1 gives you 0, so e to the 0 is 1. So does it have to be a positive 1 or a negative 1 to get negative 1? Positive, so it can't be negative. So y is equal to e to the x minus 1 minus 2. I'm not even that worried about graphing it, to be honest. Like I said, that one was fun, wasn't it? Yeah. Now, the first lesson we went over in chapter 7 was all about proportional, right?
Yeah.
bring that up for no reason, really. A here, if you're given exponential growth decay, A is your initial value. B is the growth or decay factor. So we'll say slash that. If I want the rate of change, the rate of growth or decay per year, okay, or per time or per some interval time, I would take the derivative according to time of y according to time. Okay. What is now, since a is a constant, would I even worry about a? No. And since b is a constant with the exponential of the variable, this is the derivative of an exponential function with non-base e. So I get a times b to the t times what? Natural log of b. Now, what is this right here? The same thing as y. So dy dt is equal to y times the natural log of b. All right. And the natural log of b is what? It's a constant. So dy over dt is equal to, we'll say k instead of c because we have a lot of c so far. We're not going to mess with that. And we do use a lot of k values when dealing with exponential growth decay. So k times y. Right. So this tells you the rate of change of a quantity, so that is dy dt, is proportional. Now, again, it doesn't say direct or indirect, so or inversely. So which one is it? Directly. Right. So directly proportional to the size of the quantity, so to y itself, which is what we have. If you remember, direct proportionality is just one function or one value is equal to k times the other. There it is. The rate of y dt is equal to k times y. Now, what they want you to do is just be able to set this up. What is the weight of an animal is increasing at a rate proportional to its weight. So dw dt equals kw. Now, the fact that it says increasing means that k is greater than 0. So part 2, a bacteria population is shrinking. That just means k is less than 0 at a rate proportional to its population. So we'll just use a capital P, usually for population. So dp over dt is equal to kp. Now, we just took the derivative according to time and we found our function for the rate of change of the quantity. What we're going to do now is we are going to reverse this using the separation of variables. So that means if we bring y over, 1 over y is equal to what? K, well, I forgot dy is equal to k dt. And when we integrate, what's the integral of 1 over y? Yep. Equals, now since we have what, since k is a constant, what's the integral of a constant? Kt plus c. Which means we are going to do the exponentiate both sides. We have absolute value of y is equal to e to the kt plus c, which we know what's going to happen to the c. It's going front. Now, we are only going to be dealing with positive values here. We're not going to be dealing with any negative values here, so we can drop the absolute value. Y is equal to c e to the kt. Does that look familiar? Yeah, that's what you played with in Algebra 2 and pre-calculus. So guess where that formula, again, this is calculus showing you how these formulas are created. Okay, and why we can just teach you these formulas beforehand, and now you get to see where they came from. So, here, the solution to this is y equals c e to the kt, where c represents the initial value of a model. Now, when they gave you initial value, right here, that right here, when y is 5, when t is 0, that means that c is equal to 5. All right? And this is kt, so k is equal to 6. So we have everything we need to say that y is equal to 6, not 6, 5 e to the 6t. Again, we're using that y equals c e k t. So we're going to replace c and replace k, and that's it. So what's number 4? There you go. It is x. So we are going to use this concept to create the exponential growth model. Okay. So at the animal's birth weight, weight at birth. Now again, that means that that's my c value. C equals 3. And 4 pounds later, at 4 pounds at 3 months later, the weight of the animal is increasing at a rate proportional to its weight. So that means that dw dt, which again, yeah, dw dt is equal to kw. That's what it tells you. And that means we already know that w itself, the y w value, is equal to 3e to the kt. Okay, what we don't have is the constant k. We do need to find the constant so we can plug it in to find how much will the animal weigh at 5 months old. To do that, we need a value for the w and some unit of time, which is given right here. 3 months later, so when t equals 3, w equals 4. So 4 is equal to 3e to the 3k. How do we get k by itself? 4/3 equals e to the 3k. Natural log of 4/3 equals 3k. So k is equal to what? Natural log of 4/3 over 3. Now, it's not going to be fun to type this into a calculator, so what I'm going to do is I'm going to store this as a value. One thing you do not want to do on these types of questions is round until you're done. Even just a little bit can throw things off. So we are going to put this in your calculator. We're going to type in the natural log of 4 divided by 3, close parentheses, divided by 3, and we get that number there. Okay? Now, do you know how to store? Right here is the store button. So we're going to store that. And I don't want to store as x. You can store as any other variable you want. So I'm just going to do a.
Oh, that's lame. That's so lame. Should chose better.
So I'm going to use a.
It's
And you want to do k? Okay.
W for weight.
Well, it should be better as k. That actually makes sense.
Um,
K. So we stored it as k. There's my k value. So now we have at 5 months old, so w is equal to 3e to the k times 5, and that's what we can plug in. We can actually plug that into our calculator as it is. So 3 second exponent k times 5. And we get w is approximately 4.846 pounds. Now, can anybody tell me why the pound symbol is LBS?
Because some old dude did that.
That's about as far as I know. I was actually curious. I have no idea. Anybody know? Should look it up on me.
Right now.
We got one more question. If we have time. Growth model will have a positive exponent, for example, 5e to the 2k. A decay model will have a negative exponent, which we kind of already said that. Again, growth, k is greater than 0 for growth, k is less than 0 for decay. Now, double time and half-life. The questions about double time and half-life, what they're going to do to throw you off is not give you another value. Okay? So, we are going to use that formula since this is our function. We know y is equal to ce to the kt. We know that. All right. Do we have a constant value? No, we don't even have a constant value. All we know is every 7 years, for when t equals 7, the population doubles. Now, that means if c is equal to, let's say, y0, an initial value, what would y be then? 2y0. If it doubles, what's 2 times y0? 2y0. So that means 2y sub 0. Now, it's, I say sub 0, it's actually called not. And it's not like why not, but it is called why not. Yeah. I prefer sub 0. That's all. Anyway, e to the what? 7k? Now they just want the value of k. We don't have to do anything here, just find the value of k. So, what's going to happen to the y sub zeros? Yeah, they're gonna cancel out. Okay. So we get 2 is equal to e to the 7k, which means what? Natural log of 2 equals 7k, which means k equals natural log of 2 over 7, which you can plug that in and get 0.0 something. I don't know what is it. Natural log of 2 divided by 7. 990. But yeah, there you go. I was zooming really far in. Yeah. Come on, draw here. There we go. Now, this is a double time. What do you think you would do for half-life? Yeah, 1/2 y sub 0. That's it. That's all.
I forgot the LV thing.
Oh, yeah, you think.
I just thought about top of my head. So, yeah, it comes from the wood Libra. It was a unit of weight measurement in ancient Rome.
Oh, really? Okay.
Yeah. So they and that's so you just put one half, so why you not over percent.
Libra pondo. Pound by weight.
See?
Yeah, Libra pound.
I just remember that stuff. I think it was just funny here.
Huh.
I'll figure it out.
Yeah, good to know.
Well,